question asks us how many moles of pentane are contained in 6.87 times 10 to the 19th molecules. So it's asking me to find moles when I've been given molecules. So the connection between the unit moles and the unit molecules is Avogadro's number. And you can use it to go back and forth either way. So 1 mole equals 6.02 times 10 to the 23rd molecules. Now, just remember that Avogadro's number, which is a counting unit, counts small things. So it would work just as well if they were asking to find atoms or ions. I also want to point out another observation, and that is while this says it's pentane, I don't really need to know that for this problem. So when the substance is important is when you're going from grams to moles because you need the molar mass. So I just want to write that. I'm just going to write that as the side note on the bottom. So grams and moles uses the molar mass. And molar mass is from the periodic table. So in that case, you would have to know that it was pentane, for example. But if you're just going from moles to molecules and you're using Avogadro's number, you don't have to know the molar mass because we're just counting how many there are. It doesn't matter what there is. Just as an example, if we're doing the counting unit of 12, which is a dozen, if I have a dozen donuts, a dozen eggs, a dozen friends, no matter what I have a dozen of, I have 12. So if I'm counting something small like molecules, atoms, or ions, it doesn't matter what I have, what substance it is, 1 mole of them would always contain 6.02 times 10 to the 23rd. So in this problem, we're not going to worry about that it's pentane because it's just going from molecules and moles. Let's look at how the units work that way. So 6.87 times 10 to the 19th molecules is what's given. And so in Avogadro's number, I'm going to write the 6.02 times 10 to the 23rd in the denominator, because just like we've been doing all semester, it's a unit conversion. And so if I have molecules on the top, I want to write them on the bottom or in the denominator so they cancel. Now, one important thing here for some of you in your calculator, when you're dividing by numbers in scientific notation, you will need to include a parentheses. And if you find out when you do this problem in your calculator that you don't get the same exponent as I do, go back and make sure you put in parentheses. So I'm going to enter this into my calculator. And so it's 6.87 times 10 to the 19th divided by, and I have to use a parentheses on the calculator I'm using currently. So parentheses, 6.02 times 10 to the 23rd, close the parentheses. And I get the number 0.000111412 moles. Now, at the current recording of this, the homework problem wants the answer to be written in scientific notation. So I'm going to move the decimal 1, 2, 3, 4 places to the right, which means it's a negative exponent. So that would be 1.1412 times 10 to the negative 4 moles. Then I also want to pay attention, what I was given had 3 significant figures, so I'm going to keep the 1, and the 4. I'm dropping off the 1 so it won't round. So it's 1.14 times 10 to the negative 4 moles. And again, at the current taping, how this is entered is the 1.14 is in a box. It has the times 10, and then the negative 4 is also in a box. So remember, if you're going from moles to molecules, atoms, or ions, or in reverse, molecules to moles, you're going to use Avogadro's number. In this problem, going from molecules to moles, we divide by Avogadro's number.